I want to go over two problems from our Big Ideas assignment from last class, numbers 27 and 28, the modeling problems. So in number 27, it said the function shown represents the height h in feet of a firework t seconds after it is launched. The firework explodes at its highest point. Here's the function h equals negative 16t squared plus 128t. Part A says, when does the firework explode? So the when I'm talking about is when I'm looking at this parabola, it explodes at this maximum point up here. Remember, this maximum point is the vertex. In our vertex, x and y, the x stands for time and the y stands for height. So I'm really looking for the x of the vertex. So to find the x of the vertex, I'm going to do the formula x equals the opposite of b over 2a. In our equation, our a is negative 16 and our b is negative 128. Let's plug that in. We're going to have the opposite of 128 over 2 times negative 16. So that gives me negative 128 over negative 32. And I'm going to divide those numbers using my calculator. And I get 4. So 4 seconds is when the firework will explode. Part B says, at what height does the firework explode? So now again, it's exploding at the top of our parabola, which is the maximum. The y is the height. So now let's find the y of the vertex. So I'm going to find the y of the vertex by taking the x and plugging it into our equation. So we're going to have y, or I can say h equals negative 16 times 4 squared plus 128 times 4. Let's follow the order of operations. Negative 16 times 16 plus 128 times 4. Remember to do the exponent first. And I'm going to use my calculator here. Negative 16 times 16 is negative 256. And then 128 times 4 is 512. Let's combine these two together. And I get 256 feet. So that's the height at which the firework will explode. I can also do this in my graphing calculator, and I want to show you how to do this in the graphing calculator. So I'm going to grab my calculator here. I'm going to go to y equals. Let's type the equation into y equals. So we're going to have negative 16 x squared. I don't need to put t, I can just use x, plus 128x. Now if I just hit graph, it's not going to show me the whole parabola. So I want to use the numbers that I kind of already found here and make sure that I can see everything I need to. I'm going to change the window in my graph. So go to window. And I actually still have my parameters from the last example that we changed the window. Let's see, if it's going to reach the maximum at 4 seconds, then it's going to hit the ground over here in about double that time. So let's increase this to maybe make it, I don't know, 10 seconds so I can see a little bit further. And I'm gonna go by ones. For my y's, I definitely need to get up to at least 256. Let's go a little bit past it. Let's go to 300, and we can keep our scale of 25. Let's hit graph. And there we go. There's the nice path of our parabola, and it even almost looks like the picture that we have in the question originally. So now we want to find out when and how high does this firework explode. So I want to find this point up here. Remember, this point is called the maximum. So to find this point in my calculator, I'm going to do second, calc. Remember, calc is above the trace key. And I want to choose maximum, number 4. Now I want to go to the left of the maximum. So hit the left arrow and move to the left of this point. Once you're to anywhere to the left, hit enter. Let's move to the right of this point, anywhere to the right, and then hit enter. Guess we're going to try to get right on that point, right at the maximum, as close as I can get. Hit enter. And then look at what it tells us. The maximum is 4,256. And that's exactly what I found over here on my paper, 4,256. So I can get these answers right in my calculator as well, or I can do them both by hand, which is nice. Okay, let's do the next question. We're gonna look at number 28. So it says the function h of t equals negative 16t squared plus 16t represents the height in feet of a horse t seconds after it jumps during a steeplechase. When does the horse reach the maximum height? And can the horse clear a fence that is 3.5 feet tall? So these two questions are essentially the same as parts A and B of 27. So we can go ahead and start off the same exact way. So let me write down the equation for number 28. H of t equals negative 16t squared plus 16t. We're going to do the same exact thing here. We're going to find the axis of symmetry, or the x of the vertex. We're going to do x equals the opposite of b over 2a. So in our equation, our a is negative 16 and our b is positive 16. Let's plug it in. We get negative, or the opposite of 16 over 2 times negative 16. Negative 16 over negative 32 equals positive 1/2. This is the time that it takes for the horse to reach the maximum height, and this is in seconds. So the horse will reach a maximum height. When does the horse reach the maximum height? In half a second. Okay, next, can the horse clear a fence that is 3.5 feet tall? Well, first, let's figure out how high the horse is jumping. Let's find the maximum height of the horse's jump, and then we'll see if it's taller than or higher than 3.5. So we're gonna do the same thing here. We're gonna find the y of the vertex. Let's plug 1/2 into our equation. Negative 16 times 1/2 squared plus 16 times 1/2. Let's follow the order of operations. 1/2 squared is 1/4 plus 16 times 1/2. Let's multiply. Negative 16 times 1/4 is negative 4. And then 16 times 1/2 is 8. Let's add these together. I get 4, and this is 4 feet. So that means that the horse is going to jump to a height of 4 feet. Let's answer the question now. Can the horse clear a fence that is 3.5 feet tall? Absolutely. The horse is going to jump 4 feet, which is higher than 3.5 feet. So yes. So answer the question here. Yes, the horse will jump 4 feet high, which is higher than the 3.5 feet fence. So yes is our answer to this question. Okay, let's go on to part C of this question. Part C is a little bit different, and the last question didn't have a part C. Let's take a look at what part C says. It says, how long is the horse in the air? So we can think about this two different ways. We can kind of imagine what's happening in a graph over here, and we can kind of think of what's happening. The horse is gonna leave the ground over here, and it's gonna land on the ground over here. I know that it's reaching its maximum height, and I know that this is where the axis of symmetry is gonna be. If this is at 1/2 of a second, and that's right in the middle of my parabola, I can imagine that it's gonna hit the ground at 1 second. This is 0 seconds, 1/2 is in the middle, 1 second will be all the way where the horse will hit the ground. So to answer the question, the horse will hit the ground in 1 second. Now, I can also do all of this in my graphing calculator, so let's do that in our graphing calculator and we can check all of our work. So I'm gonna go to y equals, and let's type in this new equation here. So we have negative 16t squared plus 16t, and I'm just using x's instead of t's. Okay, the first two is I'm gonna find the maximum. So I'm gonna do second calc maximum, number 4. Oh, I forgot to change the window in my graph. My window is much, much smaller because I'm only talking about a horse here, not a firework. Let's go back to window and let's fix this. So for our window, our X, look at how our X is maximum is gonna be 1. So why don't we go down here, why don't we change this maximum to be a little bit more, let's see it 2, and maybe we'll go by like 0.2 just so we can spread it out a little bit. Let's do our Y's now. We said over here that a maximum height is gonna be 4. Let's go a little bit above that. So maybe we'll go up to 10 and we're gonna go by 1s. Now let's look at the graph. Let's see how this looks here. Yep, and that looks much better. So let's double check. We're gonna do second calc maximum, number 4. Let's get to the left of that maximum point. So I'm just moving my cursor over so I can see that my cursor is to the left of the maximum. So maximum is there in the middle at the vertex. Here it is to the left, hit enter. Let's go to the right of the maximum. It's to the right, hit enter. Let's get right on the maximum, hit enter. And look at what we get. We get 0.5 and 4, and that's exactly what I found here on my paper, 1/2 or 0.5 and 4 feet. So I did get that right. Let's check part C. When will the horse hit the ground? So how long is the horse in the air? That's this 1 second here. Let's find that point in our calculator. So I want to find this point right here at the end. This point is called the 0. So let's find the 0. Second calc, choose 0, number 2. Now again, I want to be just to the left of that point. So I'm going to move my cursor over. So I'm just to the left of it. Here's the point. My cursor is to the left. Hit enter. Now let's move it to the right. So I want to go past it. And you can see my Y's turn to becoming negative. So I know that I'm past it to the right of it. So I'm going to hit enter. Let's get right on it. I want to try to get to where Y is 0. And actually I could get right there, which is great. And then here it is, our 0 is 1, 0. So that means that the horse is going to hit the ground in 1 second.